So this was pub quiz 2, which was related to projectile motion. An explosion projects a rocket into the air with a speed of 50 meter per second at an angle of 40 to the horizontal. Show that the rocket would reach the maximum height about 3 seconds after the explosion. So whenever a projectile motion, so time to reach the maximum height is 3 seconds. That is what we have to show. So it will have the two components of the velocities. One is a horizontal component and another one is a vertical component. The horizontal component, as we assume that there is no air resistance, so it will be given by F cosine 40 and it remains same. The vertical component is 50 sine 40, but the vertical component decreases as a projectile move upward. And at the maximum height, the vertical component will be 0. So the question, we have to show that the time it takes to reach the maximum height is about 3 seconds. So equation of motions are always, you use or substitute a vertical component. So if you use a formula, V is equals to U plus AT. The final vertical velocity is 0. The initial vertical is 50 sine. So this will be 0. This will be 50 sine 40. Acceleration it is moving against the gravity. So minus 9.8. So this will be 9.8 and T. We move 9.8 other side will become plus 9.8 and divide. So T will be equals to 50 sine 40 divided by 9.8. So 50 sine 40 divided by 9.8. That will be equals to 3.28 seconds. So 3.28 seconds, that is the time it takes to reach the maximum height. The second part, the rocks moves in the direction of the hill at an angle of the side of a hill is at 20 degrees to the horizontal. After a certain distance, the rock lands on the side of the hill. Deduce whether the rocks hits the ground before it reaches the maximum height possible. So how we can work out this 6-mark question? Whenever there's like a 6-mark question is there, it means you have to use at least 2 or more formulas. So first, we already worked out the time. We already worked out the time it will take to reach the maximum height. What we'll do, we'll find the maximum height, and from that maximum height, we will work out the, like from the horizontal component. Using a horizontal, we can also work out the range, and from the range, we can work out. So the rocks move in a direction of a hill, and the hillside is 20 degrees to the horizontal. So this is a hillside which is 20 degrees to horizontal. And after a certain distance, the rock lands on the side of the hill. What we have to deduce whether the rocks hits the ground before it reaches a maximum, like maybe the rock may hit this part before reaching the maximum hillside. That is what we have to tell. So how it can be done? The angle is given 20. So first we'll find the maximum height it will reach using the equation of motion. S is equals to ut plus half at square. The initial velocity, that is the word, because what we are doing, we are finding the maximum height this will reach. And using the hillside, we can also work out like what is the height of this hillside. The angle is given. So we use a formula. S is equals to ut plus half at square. The initial velocity is given by a formula. It will be 50 sine 40. So this will be equals to 50 sine 40 plus 1 by 2. Acceleration is due to gravity 9.8. And the time, it was 3.28. So we substitute 3.28, and here it will be 3.28 square. What is the maximum height? When you calculate this, you will get the maximum height. So this will give you 53, about 52.6. So we got 52.6 meter. That is a maximum height. That is a maximum height which this projectile will reach. Because the projectile, when it is launched, and this is a hillside, so we have to show that maybe it might cross the hillside, or maybe it landed on the hillside. Like it landed on the sideway, as you have, after a certain distance, the rock land on the side of the hill, and reduce whether the rock hits the ground before it reaches its maximum height. So the maximum height reached by this projectile, it is 52.6. That is the maximum height which this projectile will reach. Now we will find how much range will be there for this projectile. So we worked out this maximum height. Now using this maximum height, we'll work out the distance. So to work out the distance, we'll use a horizontal component. That is a maximum range. This will be speed like multiplied by time. Like time to reach the maximum height, we are finding when it is at maximum height, how much distance it has covered. That we are working out. So the maximum height, it was 52.6 meters. The initial launching speed was 50, and it was the horizontal component is cosine 40. So this will be the horizontal component multiplied by how much time it took to reach the maximum height. That time was 3.28 seconds. So we will get the range of this projectile by using 50 cosine 40 times 3.28. So when we multiply, we'll know at how much distance it has covered when it is at the maximum height. So when it is at a maximum height, how much distance it has covered? So you multiply them. It will be like 50 cosine 14 to 3.28. That will be 125 meters. So the horizontal distance, the range is 125. Now, what is the height of this hill? If the horizontal distance, like at 125 meters, because we worked out that when rock is launched, the horizontal distance which the rock has covered is 125 meter when it is at this maximum height. Now we are finding what is the height of the hill after 1.125 meters. So this is 125. The height of the hill we don't know. We say h, and the angle of the hill is 20 degrees to the horizontal. So you have like you have the perpendicular we need, we have the base, and we have the angle. So we can use tangent theta, which is perpendicular divided by base. So it will be tangent 20 is equals to perpendicular the height, and the base is 125. 125 is divided, other side multiplied, so 125 tangent 20 is equals to height. So 125 10 multiplied by 10 20 degrees. What's the answer for this? 125 multiplied by tangent of 20. 45. So this height is 45.7. And what was the height of the projectile? 45.4 or 45.5. So, and what is the height of the rock at the maximum height? So at the maximum height, the height of the rock was around 52.6. So means this rock will not hit the hillside at its, it will reach its maximum height, because if the height, like example, the maximum height was less than 45, then this rock will likely hit the hillside before reaching a maximum height. Like when it is going up, it might hit the hillside. But here, this won't hit. Why it does not hit? Because the maximum height of the rock is much greater than the height of the hill. So that's why it won't hit the hillside. Is it clear, this question?